Hi, welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers of the Space Telescope Science Institute. Today, we're going to talk about discovering planets. Now, in our solar system, we've known about planets for a long time. Matter of fact, this is our solar system with Mercury, Venus, Earth, Mars, and on out to Jupiter. These planets plus Saturn are planets that you can see without the aid of a telescope. We call them the naked eye planets. And so these planets weren't ever really discovered. We did, however, discover other planets in our solar system, and we didn't discover the first one until 1781. In 1781, William Herschel was looking at double stars in the sky. He was doing a study about double stars, and he was looking in the constellation Taurus, and we've recreated it here. And in looking at Taurus, he saw this fuzzy star here that didn't appear on his star charts. So he wondered, what is it? So he looked a few days later, and he found that that star was gone and had actually moved to a different position. And so, by seeing it on one day here and on another day here, seeing it move against the background stars, he could deduce that this must be a solar system object, simply because solar system objects move quickly across the sky, and stars, well, they're relatively stationary. He was able to then announce to his astronomer friends that he had discovered a comet. Now, wait a minute, we're discovering planets in this show, aren't we? Well, no one had ever discovered a planet before. So Herschel wasn't going to say, oh, I've discovered a planet. What he would expect to discover would, of course, be a comet. However, upon observing this object, they found that it didn't move the way a comet would. It wasn't in the inner part of the solar system where it would be moving much faster across the sky. Instead, when they followed its orbit, they deduced that its orbit was twice the distance of Saturn from the Sun. This is an object way, way out in the solar system, and to be seen this bright, it was soon concluded that it was a planet. We now know of it today as the planet Uranus. Now, Uranus plays a major role in the discovery of the next planet in our solar system, because astronomers went and looked back and found that other people had seen Uranus over 100 years earlier. And from that, they could compute a very accurate orbit. Well, Uranus didn't follow that orbit. Uranus kept straying ahead of its predictions and behind its predictions. And these predictions are based upon all the gravity we knew about in the solar system, the gravity of the Sun, the gravity of all the other planets. But Uranus wasn't going where it's supposed to. So, two mathematicians, John Couch Adams in England and Urbain Le Verrier in France, took up the question to figure out what was causing these perturbations in Uranus's orbit. And they concluded that there had to be yet another planet out beyond Uranus. And when astronomers looked for it, they found the planet Neptune. Neptune was actually predicted by mathematics due to the theory of gravity before it was ever observed. This was an amazing feat of science. So that's how we filled out our solar system, going all the way out to from the inner planets through the outer planets. But we're really not talking about our solar system in this episode. What we're really going to focus on is discovering planets in other solar systems. You may know that we know of over 300 planets around other stars, and some of them form planetary systems. For example, this is the planetary system around the star 55 Cancri, which basically meant it was the 55th brightest star in the constellation Cancer. The outer planet in 55 Cancri has an orbit that's about the same size as Jupiter's orbit. The next in planet has an orbit about the same size as Venus, and then there are 3 more planets way down in here next to the star that all have orbits smaller than Mercury's orbits. These planets range from Neptune-sized planets all the way up to one planet that is 4 times the mass of Jupiter. So although some of the orbits are sort of like our solar system, the distribution of planets, putting a Jupiter-sized planet in Mercury-sized orbits, isn't really like our solar system. Now, these planets have not actually been seen. I can give you the parameters of it, but these planets haven't been directly observed. We only know about these planets due to their gravitational effects. Just like Neptune caused an effect on Uranus, These planets cause an effect on their star. A large planet, as it orbits around its star, pulls on that star, and that star sort of wobbles a little bit. And that little bit of wobble by the star can be detected in spectroscopy. So we've deduced the existence of these 5 planets due to that little tiny wobbles that they induce in their star. So we don't actually see these objects. I can't show you a picture of what they look like. Matter of fact, none of the 300 or so planets that we've ever seen have actually been seen. We've only detected them by indirect means. Well, that was true until late 2008, when Hubble made an announcement about this star, the star Fomalhaut, which is the brightest star in the southern constellation Piscis Austrinus. Matter of fact, Piscis Austrinus means southern fish. And this is Hubble's image of the star Fomalhaut. And you may say, wait a minute, that doesn't look like a picture of a star. It looks more like an eye. Well, you're right. It isn't a picture of a star. And yes, it does look like an eye. It's actually a picture of everything but the star. Fomalhaut is located right here. And what we have done is we've used a coronagraph. And now, a coronagraph is a really simple thing. You've done it yourself. When you're driving down the road and the morning sun is up in front of you and you put your hand up to sort of block the sun so you can see the road, well, that's exactly what we're doing. We're blocking the light of Fomalhaut so we can see the faint stuff around it, so that we can see the details of the planetary system around Fomalhaut. And what's cool about the details around Fomalhaut is this ring here, this ring that goes across here and around here, all right? That ring of dust indicates that there is a system, that there's a planar system, just like our solar system, around Fomalhaut. And, well, I got to say that just having a dust ring isn't what really makes it special. What makes it special is that this dust ring is not centered on Fomalhaut. If you do very careful measurements, you can see that this dust ring is eccentric. It's stretched out into an ellipse. So the question then becomes, what would cause it to be stretched out? Well, somebody went through the mathematics and figured out that if you had a planet in the right orbit, it would cause this dust ring to deviate into an elliptical orbit. So they made a prediction that somewhere in this image there would be a planet. The problem is, where would it be? There's a bright dot down here, and one there, and one here, and one here. How would you be able to tell what it is? Well, it turns out that it is this dot right here, and the way we can tell is the same way that we discovered Uranus, by watching it move across the sky. So, in 2004, this is the image of the object in 2004, and by 2006, it had moved to here. Okay? And you can tell this is really, really difficult because it's really just a few pixels, and this is really tiny, faint stuff. But if you fit an orbit to this, and you match it to what was predicted for the planet, this is the Fomalhaut planet. This is the first time in history we ever have an image of a planet. I gotta say, it's not that impressive, but anything at the cutting edge is never that impressive. It's just a few pixels. But we now have a planet that we have actually seen. There is, however, one problem. We shouldn't have seen it, because this planet is predicted to be just a few times the mass of Jupiter. And at that mass, and at a great distance from its star that it is, it shouldn't be bright enough for even Hubble to see. And that raises a quandary. Why are we seeing something that we shouldn't see? Well, the hypothesis is this, and this is an artist's impression. You have the planet here, and we give it a really basic name. We call it Fomalhaut B, whereas A would be the star, B is the planet, okay? So we have Fomalhaut B here, and then we have this disk of dust around the star, up around the planet Fomalhaut B. Now that's different from the dust ring that's around the star Fomalhaut A, all right? So this dust ring around Fomalhaut B reflects much more light because it's like 10 times the size of the planet. And the combined light from the planet and from the dust disk allow us to see the planet that we otherwise wouldn't be able to see. So, you may ask, how does this planet compare to our own solar system? Well, let me remind you of our solar system. And we have our inner solar system and the giant planets out to Neptune. And one thing I've added in here is this blue fuzzy material here. This is a disk of material called the Kuiper belt. It is an icy disk, debris disk in our own solar system. We also have the asteroid belt in here, which is a rocky debris disk in here. And I want to compare that to the dust ring we see in Fomalhaut B. Here is the Fomalhaut system. Here the star Fomalhaut. Here is the planet Fomalhaut B. And here is that dust ring around the star. What you will notice is that Fomalhaut B is right on the inside of that dust ring, just like Neptune is just on the inside of the Kuiper belt. So it is controlling the orbit and shape and distribution of this dust ring, much in the way Neptune actually controls the same parameters for the Kuiper belt in our own solar system. The major difference here is that the diameter of Fomalhaut B's orbit is 4 times that of Neptune's orbit. So it is in some ways similar to our own solar system, but its scale is much, much larger. Now, if that were the only discovery we made, that would be fantastic. But on the same day as this announcement was made, and as a matter of fact, in the same journal as this announcement was made, the Gemini and Keck observatories made an announcement about the star HR 8799. They had also discovered planets around this star, and it's these red dot here, and a red dot here, and a red dot here. Not 1, not 2, but 3 planets around HR 8799. Let me put some arrows on them so you can see where they are. Now, this image is kind of difficult to explain because this is a ground-based image using adaptive optics, and all of this speckling in here is basically, what happens when you're trying to subtract out the light of the star. So this is all just gobbledygook from the observation, but they have the observations of the 3 planets, and they have them at different epochs. They have them over the course of several years, so they can follow their motion to confirm that, yes, they are planets, and they are orbiting HR 8799. But wait, as they say, there is more, because these 2 announcements stimulated yet a 3rd announcement 1 week later, and that announcement was about the star Beta Pictoris. Now, this image is really confusing, okay? So don't try to understand it straightforward. This is the dust disk around Beta Pic, and this is a mask to show you where they're trying to subtract out all the light and everything. But what you really want to pay attention to is just this white dot here, this small white dot here, because they believe that this is a planet around Beta Pictoris. Now, this group does not have any time sequences. They don't have images from years ago, so they will have to wait a few months to a few years so that they can prove that this orbits in a planetary-style orbit around Beta Pic. But it appears that if you add in the 3 planets from before, planet from Beta Pictoris, and this planet from Fomalhaut, we now have 5 planets that we have seen directly. 5 planets that we, instead of just inferring their existence, we've actually observed them. This sets us up for a brand new era. An era when we can not just, we can talk about these solar systems, but we can actually show them to you. And I really look forward to being able to see much, much higher resolution of images from telescopes to come. So to bring us back full circle, this image, this planet around Fomalhaut, was discovered using a combination of the techniques that we use to discover the planets in our own solar system. It was predicted due to gravity, just like Neptune, but it's not confirmed until we see it move across the sky, just like we did for Uranus. Now, I can make a very simple prediction. I can predict that we will see a lot more of these. Now that we know what we're looking for and how to look for them, we're going to have a lot more new discoveries, and it's a new era of looking at planets around other stars. That's all for today. We'll see you next time on Hubble's Universe Unfiltered.